In Algebra 1, Section 2.6, we're solving compound inequalities. So basically, a compound inequality is an inequality with two inequalities combined together into one statement, okay? And I use either and or to combine them together. So this inequality is true and this inequality is true, or this inequality is true or this inequality is true, okay? For example, pH levels of a pool. When you're doing the acidity of a pool, you want to make sure that the pool is clean for people to get into, but you don't want you don't want the chlorine to be too acidic that's cleaning the pool, or else people can't swim in it. It'll start hurting. Okay, so I can have it between these two. All right. Same thing with speed on the freeway. You can get a ticket actually for going too slow on the freeway or too fast. So you have to stay in between. Both those statements are examples of and inequalities. Like it has to be this and this. So it has to be between these ranges. Okay? So for example, x is greater than 2 and x is less than 2. So what that's telling me is that x needs to be, this is 2, this is 6, and this is 2. X needs to be bigger. X needs to be bigger than 2. Okay, and it needs to be less than 6. So where these combine right here, this is where your answer lies, in between. So you can actually rewrite an inequality, okay, to look like this. X has to be between 2 and 6. It has to be bigger than 2, but smaller than 6. So it's between, here's 0, here's 2, and here's 6. Because there's no line underneath, I have two starting points this time, okay? And the answer is between the starting point, okay? For the next one, it's different because there will be, see how this one overlaps? The next one, there is no overlap. So I'm not putting in between, it's either one is true or the other. So here's 0, here's 2, and here's 6. So, and remember, these starting points are circled in because they have that line underneath. So it needs to be less than 2. X needs to be all the numbers smaller than 2, or all the numbers bigger than 6. So there's no overlap, it's the other extreme. So you see the difference? And looks like this in between, or is the other extreme where there's no overlap. So if we're going to solve and graph this, let's solve this one. Because there's, for the ands, when there is an x in the middle, you're isolating the x. So remember that rule, whatever I do to one side, I have to do to the other? Well, in this case, if I have three different sides, whatever I do to one side, I have to do to the other sides, okay? For these ones, I just treat them like two individual equations, so that's a little bit more simpler, okay? So for example, I want to get x by itself, and I want to first get rid of its, friends, okay? The furthest friend is -1. And in a typical equation, in order for me to get rid of -1, I have to do what? I have to add 1. Now, because I have 3 sides, instead of me adding 1 to just this and another side, I'm going to do it to all 3. So add 1, add 1. You see how that works? Okay, so this becomes 9. I bring the signs down. 3x, because this cancels out. And then less than or greater than 12. Okay? And then for this one, if I want to get rid of the 3 because it's connected by multiplication, I have to divide. So I'm going to divide this by 3 to get rid of that, leaving me with just x. But whatever I do to 1, I have to do to all the other sides. Now this rule works the same way even if I have equal signs on both sides. It doesn't matter. But when I have 3 things, it's the same thing, except what I do to one side, I have to do to the other. So I'm going to divide by 3. 9 divided by 3 is 6, which is less than x, which is less than or equal to 12 divided by 3 is 4. Okay? So this is telling me that my answer is between 6 and 4. But pay attention to the signs because one is open circle and the other one is closed circle. So here's 0, here's 4, and here's 6. So 6 related to x is open circle, and 4 related to x is closed circle, and it's in between. That means my answer can include 4, but it cannot include 6. All right? Okay, let's try the next one. These ones are a little simpler because I just treat them like two separate problems. So if I want to solve for x here, I have to get rid of the 4. If it's being multiplied, well, I'm going to go ahead and divide both sides by 4. Okay, so if I'm dividing both sides by 4, I'm going to cancel this out. This gives me x is less than or equal to 20 divided by 4 is 5. Okay, I'm going to bring that or down, and for this one, I'm going to do the same thing when I'm dividing by 3 to get rid of. So I end up with x is greater than 7. So if I wanted to graph this, here's 0, 5, 7. It's closed circle with 5, and it's all the numbers less than 5. But it's open circle with 7, and all the numbers bigger than 7. So this is my answer. So go ahead and write this down and try page 138, numbers 4, 9, and 14. Page 138, numbers 4, 9, and 14. And I'll see you in class.